Here in Boise, Idaho, we have quite the K-9 unit. Our senior pup, Miss Scout, is our star pupil with a state record of 4,500 cocaine fines. She's got quite the sniffer, folks. Today, we have a new trainee, Gohan. He's watched the K-9 unit on TV ever since he first opened his little puppy eyes, and he's been looking forward to being a big enough pup to start his training.
That was amazing! How do you do it? I want to try.
Oh boy, slow down. First you gotta learn the basics. Let's go into the K-9 classroom. Okay, Gohan, first things first. Do you know what cocaine is?
A drug?
Good start. It's a Schedule II drug that is prevalent to our community. Cocaine can make someone feel super duper euphoric and energized, but it is extremely addictive and harmful to the humans.
Why is it so addictive?
That's where it gets complicated. If we go inside our heads, we get our brains that have the mesolimbic dopamine system. Normally, dopamine is released when something pleasurable happens, like a belly rub.
You've got my attention. I love belly rubs.
Dopamine gets released by a neuron in a synapse, and it binds to a dopamine receptor and makes you feel good. After your belly rub is over, transporter proteins on the presynaptic neuron remove dopamine from the synapse.
So what does that have to do with cocaine?
Alright, so cocaine is able to move from the blood to the brain, where it inhibits the dopamine transporter, leading to accumulation of dopamine in the synapse, and more receptors become bound. When so much dopamine being bound, it's no wonder people experience euphoria and increased energy.
So it's like getting the best belly rub ever, so people keep using it?
Exactly. You're catching on quick, pup. Not only is it addictive, but cocaine's half-life is only 40 minutes, which means the humans feel the effects wear off quickly and immediately feel like they need more.
Wow, that sounds like it's a slippery slope.
It really is, which is why we need to help get it off the streets. Are you ready for your first lesson?
I was born ready.
Okay, Gohan, let's see what your sniffer can do. You won't find anything in there. You gotta know what you're sniffing for. Do you know what cocaine smells like?
Yeah, drugs.
Yes, but specifically, you're sniffing for methylbenzoate, which is the dominant odorant associated with cocaine. Since a dog's sense of smell is 2,000 times stronger and 50 times more sensitive than humans, we are more successful in finding methylbenzoate.
This looks like a fun towel to play with, but it smells sort of funky.
I'm so proud of you, little pup. You did it. It smells odd because our humans laced it with cocaine so we can learn to recognize the smell, but be careful not to sniff too much. It's toxic to dogs.
Okay, I'll be careful, Miss Scout. I feel like a good boy for finding that towel, but I don't know how I did it.
How about we go back to the classroom to catch up, silly dog brain. So you're wanting to know how we smell things, right?
That's right, Miss Scout.
All right, it's a bit complicated, so stay with me. So we have chemoreceptors in the olfactory epithelium high in the nasal cavity. The chemoreceptors are bipolar olfactory neurons that send signals to the brain whenever an odorant binds to them. There are also basal stem cells that constantly produce new olfactory neurons, so our sniffers stay sharp.
Like cheddar.
Sure?
Speaking of cheddar, how do the neurons know whether I'm smelling something yummy like cheese or something funky like that towel I smelled earlier?
Great question. One neuron has all genes for anything you could imagine smelling, but only one of these genes is turned on at a time. So each neuron has only one type of chemoreceptor. And guess what, Gohan?
What, Miss Scout? Tell me.
Methylbenzoate binds to one of those receptors.
What's methylbenzoate?
Cocaine. It's cocaine, Gohan.
Oh, yeah, I knew that. So you said the odorant binds and then a signal is sent to the brain? How does that work?
Another good question. Let's back up a bit. The receptor that the odorant binds to is a G protein coupled receptor on the membrane of the neuron. A G-coupled protein receptors have 3 subunits, alpha, beta, and gamma. When the odorant binds to a molecule called GDP, it is exchanged for GTP. This causes the alpha subunit to dissociate from the other subunits. The alpha subunit activates a protein called adenyl cyclase, which converts ATP to a secondary messenger called CAMP. CAMP binds to ligand-gated sodium channels on the cell membranes, and sodium enters the cell. Does that make sense so far?
Yeah, but all this is happening in one cell. How does it go to the brain?
Well, the entry of sodium causing depolarization where the inside of the cell becomes more positive. If the scent is strong enough, an action potential will be reached, leading an influx of calcium and exocytosis of neurotransmitter vesicles. The neurotransmitters travel to the postsynaptic neuron. In this case, these postsynaptic neurons are the mitral cells of the olfactory bulb above the nasal epithelium. The neurotransmitter binds to the mitral cell, which propagates another action potential. The action potential travels down the mitral cell's axon to the olfactory area of the cerebrum. Your brain processes the signal, and that's how you know what you're smelling. Get it?
I think I got most of that. You're so smart, Miss Scout.
Well, shucks, that's nice of you to say. I've done a lot of research on this topic, so I guess I'm a good retriever of information.
Oh, good one. I've learned so much. I feel like there couldn't possibly be anything else for you to teach me. I'm ready to head out the Labrador and get to work.
Nice try, rookie. But leave the puns to me.
Suspect on run after drug bust. Send out K-9 units.
Scout, does that mean it's finally time for us to do our job?
Yes, come on! We gotta go!
Who let the dogs out?
Do you smell it yet, Gohan?
I'm smelling it. I think it's that guy who's been running from us for the last 5 minutes.
That's a safe bet. Go, go, go! Good boy, Gohan. You got him. Let the humans take over from here.
Bad boys, what you want, what you want, what you gonna do? When Sheriff John Brown come for you. Tell me.
So what happens now?
Well, we wait until they finish up with the bad guy, and then our humans will give us a treat when we get back to the station.
From this story, we learned much about cocaine and how drug dogs are trained to detect them. The duo went on to be the most successful K-9 unit Boise has ever had. Scout eventually retired and Gohan continued to follow in her paw steps.